Swayam Prabha. Digital India. Educated India.
Welcome back to the lecture series in animal physiology. So, we have talked about the detailed anatomical architecture of the arteries and the veins. Then we talked about how from the heart the vessel diameter changes and then it becomes capillaries, fenestrated capillaries, and then it becomes veins like the venules, veins, the larger veins, and so on and so forth. Today, we will discuss some of the terminologies which I believe will be very essential for you people to kind of have a basic understanding. And now, this will be talking mostly about the physiology part of it. We have talked about the anatomy, now we will be dealing with the pressure, vein pressure, arterial pressure, and all those, and what are the terminologies and how some of these parameters, the surface area influences all these things, the volume, surface area, and all that stuff about the blood vessel. Okay. So, coming back to, okay. So, we are into, this is our week 11, lecture 4, W11 L4. Okay. Now, the first some key terms and relationship that we will be discussing, some key terms and relationships pertaining to blood circulation. Okay. Pertaining to blood circulation. So, first one is the blood flow. What is blood flow? Denoted by F, the volume of blood flowing per unit time through a vessel or a group of vessels. The volume of blood flowing per unit of time through a vessel or group of vessels, through a vessel or a group of vessels. Mark this word, or a group of vessels, may refer to circulation through a capillary, tissue or organ or entire vascular architecture. Total blood flow is equal to cardiac output. Total blood flow is equal to cardiac output. This is the first definition what you needed to know. Then comes blood pressure. And I am just putting all these things in front of you so that you get time to regurgitate through this definition. The hydrostatic pressure in the arterial system. The hydrostatic pressure in the arterial system. That pushes blood through capillary bed, that pushes blood through capillary bed. Okay. The third definition in the same line, third definition, important definition, is circulatory pressure. What is circulatory pressure? So, we have talked about the blood pressure. So, the pressure difference between the base of the ascending aorta and the entrance of the right atrium. So, the pressure difference between the base of the ascending aorta and the entrance of the right atrium and the entrance of the right atrium. This is called circulatory pressure. So, you should be able to distinguish between the blood pressure and the circulatory pressure. This is very important that you kind of try to understand that there are several terminologies which you will come across, but unless otherwise you think through it, you will get confused. So, one more thing which I wanted to highlight, whenever you talk about blood pressure, so you get two values, that higher blood pressure, lower blood pressure, but did it ever strike you, like after seeing this structure what we were drawing, that all throughout this structure the blood pressure is changing? See, there is nothing called uniform. So, just think of it, because at every point the vessel architecture is changing. So, automatically if pressure is force per unit area, where F is the force and A is the area, so then at every point the force with respect to the area is changing, because the area is changing, whether force changes or not, but the area is continuously changing, the cross sectional area is continuously changing. So, whenever we give two values, say we say high blood pressure and low blood pressure, you have to realize that blood pressure is a continuous thing. What we do is an averaging it out. What does that mean is something like this. So, based on the vessel, based on wherever, and so the way blood pressure changes, or something like this. So, what we do is we kind of draw a medium line, and then we have the lowermost value and the uppermost value. So, it is a continuous thing, it is an averaging it out. So, please keep that in mind. That is why I am kind of walking you through these fundamental definitions, because these definitions will be very helpful to understand these basic concepts. Okay. So, now coming back to the third key definition, which is your hydrostatic pressure. You have come across this word, I did not explain it purposefully at that time. So, remember where we talk about hydrostatic pressure, but then what is hydrostatic pressure? Now, we are explaining what is hydrostatic pressure. Hydrostatic pressure. Okay. Hydrostatic pressure is the pressure exerted by a liquid in response to applied force. Hydrostatic pressure is a pressure, and this is all in the context of circulatory physiology we are talking about. A pressure exerted by a liquid in response to an applied force. In response to an applied force. That is the hydrostatic pressure. Now we will talk about peripheral resistance. Peripheral resistance. What is peripheral resistance? Okay. So, peripheral resistance is the resistance of the arterial system. PR is the resistance of the arterial system, the resistance of the arterial system affected by such factors as this part is critical, affected by such factors as, now here keep a close eye. What are the factors which are affecting? Vascular resistance, viscosity and turbulence. Vascular resistance 1, viscosity and turbulence. Now, the reason why this you will be able to appreciate it better is if you look at in the previous class I talked to you about these kind of things, aneurysm or arteriosclerosis, how these things are affecting all this stuff. Now, in the light of it, think of it. Peripheral resistance PR is the resistance of the arterial system, and this is all in the arterial system happening, affected by such factor as vascular resistance, viscosity, so and turbulence. Now, when we talk about the viscosity, what we mean? So, the blood has certain fluidic properties. It is made of particles, and as we will go to the next, what will be going post this week, we will be going for the blood composition and all. You will realize the blood consists of cellular particles in the form of RBCs, WBCs, platelets, and lot of proteins which it is carrying, and it is suspended in a fluidic medium which is aqueous. It is kind of a watery medium. So, it has a pre-calculated viscosity, but now if the amount of particle increases in the blood, so the viscosity changes. As soon as the viscosity changes, it exerts different level of pressure on the walls. So, that is what it meant by here, the viscosity, and because of the viscosity there may be a turbulence in the flow, because now it is kind of putting different kind of unusual pressure, and with the changing diameter like this, where the diameter is narrowing down like, so there may be turbulences, there may be eddies which are getting formed at places, there may be you see. So, apart from it, if there is a thickening of the vessel, then you get a vascular resistance. So, these are very complex equations by virtue of which many a times doctors had to figure out that what is really happening in the patient. They needed all these different values. Okay. So, this one is the peripheral resistance. Now, we will move on to the next one, which is basic resistance in the blood vessel. So, the basic resistance is the force that opposes the movement of the blood flow. Force opposing the movement of the blood flow, in this case the blood flow, opposing the movement. Okay. This is your basic resistance. Okay. Then we come total peripheral resistance. Total peripheral resistance. So, total peripheral resistance is the resistance of the entire cardiovascular system. The resistance of the entire cardiovascular system. Next is your turbulence. We haven't still defined turbulence. So, turbulence is a resistance due to irregular swirling due to irregular swirling movement of blood at high flow rates okay, or to exposure of irregular surface. Exposure to irregular surface. Now, if you look through this definition, a resistance, so basically you are getting a resistance on the due to irregular swirling movement of the blood at high flow rates or exposure to irregular surface. Now, this is say the original surface. Now, on this you have, say for example, you have deposition places. This deposition ensures this becomes an irregular surface. Because of this irregular surface, so the flow of the blood, which otherwise was following a possibly a laminar profile, is now started to take a different kind of geometry, which essentially means irregular swirling motion of the blood. And this becomes even much more critical if rate of flow is going up. Then this forms what we call as something like this, the eddies. And now, in the light of this definition of turbulence, if you look at what is happening in aneurysm is something where the blood vessels all of a sudden changes shape like this. So, part of the vessel curls back. So, the blood is coming like this, then it is traveling and so these kind of structure, these kind of irregularities which are approaching in the structure causes a lot of unusual pattern of flow, and that at times may lead to rupture of the vessels, hemorrhage, and several other complications into the vessel. Okay. So, we will close in here, and the next class we will continue with it, and we will wind up this part of the segment where we talk about the vessels, vessel architecture, and the physiology of the vessels. Thank you.